Question 7, IAL Jun 16, the last question on the paper, and this time it really is the last M1 question I'm going to do, exam in a couple of days. Right, okay, so we've got a situation here where it's in limited equilibrium. That means it's on the point of slipping, and it's on the point of slipping down the first plane. And they've given two angles here, alpha and beta. And it's on the point of slipping down this plane here. Okay, so that means that friction must be up the plane. There. Let's mark on an angle, a reaction force R there. And there's a weight of 4G there. I'll mark that T. The T I'll mark on here, like that. And this will be the frictional force, and because it's in limiting equilibrium and we're told the coefficient of friction of that plane is 1/4, I can just cut to the chase and call that 1/4 R and mark it on my diagram. It's okay to do that. And then we have a smooth plane here. It says the second plane is smooth. It says particle pulley, it says that somewhere. It says it's a smooth pulley. And it says the second plane included alpha and particle P on the first plane and particle Q on the second plane. And somewhere it says it's smooth. I found it smooth there. Then mark on reaction force. We're not going to give it assign a letter to a symbol to it because we don't really need to know it because it's a smooth plane. So we've got a tension there because they've got to be the same because there's a smooth pulley, so the tension's got to be the same throughout the string. And we don't know the mass. In fact, that's the first thing we're being asked, I think, mg. And then we need to set up some equations. A good diagram is a good place to start. I'm going to start because it's given the two angles. So I'm going to start working with the angles. If you've got tan alpha equals 3/4, then we can just because it's a 3, 4, 5 triangle, we can easily convert to sine alpha is equal to 3/5 and cos alpha is equal to 4/5. Just drawing up a 3, 4, 5 triangle. And then with tangent beta is equal to 4/3. Here we'll have sine beta is equal to 4/5 and cos beta equals 3/5. I tend to like to work with the angles like that rather than use a calculator. Well, it's easily verified using a calculator, those. So now let's just do some resolving. We're going to need to know the reaction force. So let's just mark in some angles on the diagram. We've got an angle alpha here. Okay, so we need to know the components, those two components we're going to use to actually set up our equations. Let's resolve perpendicularly. So for particle B, resolving perpendicularly, we've got this component here which is next to the angle marked alpha there. So that's R cos alpha, it's 4G cos alpha equals R. I do prefer not to sub in the actual values just in case we've made a mess of this. It's easier to read. So 4G cos alpha, the examiner can see that we've resolved. So it just makes more easy to read rather than doing a substitution straight away. I know we're at 15 now. Over 5. 16G/5 is R. Right, so now we can resolve parallel for P. So if we resolve parallel for P, we have the T going upwards, and we've also got friction acting upwards, which is 1/4 R. Again, I'm not going to prematurely substitute in the 16G/5. I always say the first equation should really be the basics without any kind of calculations, just to resolve an equation. So T plus 1/4 R, And then we want the component of the weight down. Because the angle is mapped alpha here, and this is away from the angle marked alpha, that is 4G sine alpha. Okay, so now I'm going to start doing some work on this. T plus a quarter times R, which is 16G over 5, equals to 4G times sine alpha, which is 3 over 5. I'm not going to do anything more than just simplify that a bit. We have T plus 4G over 5 is equal to 12G over 5. So that's as much as we can do now. Well, I suppose we can now, it's not quite true, we can now go further and then say T is equal to 8G over 5. Okay, so we've worked out T, and then now we can start looking at the resolving for this equation here. And again, we split the weight into two components, parallel and perpendicular. We've got the angle beta here, and we're not interested in the reaction force here because it's smooth. So all we need is an equation for T, resolving parallel, and the component will be sine beta. So we can say that we're looking at particle Q, that the component of the weight down the slope, which is mg sine beta, is equal to the tension going up the slope. So, but we know sine beta is 4 over 5, so we have T is equal to 4mg over 5. So now we've got two expressions for T. So we have 8g over 5 is equal to 4mg over 5. Pretty easy to see from that with everything cancelling, that m is equal to 2 kilograms. Okay, so that's 10 marks done. And then the next question is to find the force on the pulley. Okay, let's draw the force exerted on the pulley. Let's draw the diagram up again. Okay, so there's the diagram. And we want the force on this pulley. Now the one thing to recognise is this is a right angle. We can easily verify, this isn't a C3 paper with advanced trigonometry, but actually tan minus 1 3 over 4 plus tan minus 1 4 over 3 is equal to a right angle. And because of that, it's a right angle in the triangle as well. And that's always the case. In fact, if you've got the tan minus 1 x plus tan minus 1 over x is always equal to 90 degrees, but I digress, that's not really, this isn't a pure paper, so basically it's a right angle. I'm sure you can easily verify that. One of them's 36 degrees here and one is 37 degrees, the other one's 53 odd degrees. You can easily work out that's right angle. So we've got T, which is 8g over 5, going down like this. We've got a right angle, and we've got a T and a T there. Right, so we can easily just use a triangle of forces or a parallelogram of forces, whichever you prefer. We've got a right angle here, and that's T and that's T. A very good diagram, let's try and do it better. So this is a triangle of forces here, that's a parallelogram of forces. I tend to prefer to work with the triangle. 8g over 5, 8g over 5, because they're both equal to T. And we want the overall force, and we can use Pythagoras, so we can say F squared is equal to 8g over 5 squared plus 8g over 5 squared. So F equals to the square root of those two added, or square root of 2, 8g over 5 squared. That in exact terms, it's not asking for exact, would be equal to 8 the square root of 2 over 5g, if you want an exact answer. But this is M1, I'm not sure, I haven't looked at the mark scheme to see if they'll accept exact. It's actually nice, of course, for those who like the old school with their stuff, but we've got to give free significant figures. 22.2 newtons is the answer for that force. Now there's a strange, a little bit unusual, because only one mark. Find the direction of the force on the pulley. There's only one mark on it. Now I've looked at the mark scheme for this particular bit. It's a little bit strange because it says it's the perpendicular bisector of them, which of course it is, because this is an angle of 45 degrees. But basically, if I saw this exam off the bat, I think I would just give what the angle is. So let's just do that. And they do accept that, so I've looked at it. So, but it's a bit strange for one mark. It's quite a lot of work to do for one mark. Anyway, we know this is 45 degrees. We know the resultant. We know that's 45 degrees. There. Okay. But we also know, there's a marking on here, this angle here, that angle there is equal to tan minus 1/3. It's the same as alpha. You can play with the angles if you like. And alpha is equal to tan minus 1/3/4. And for the first time, I'm actually going to work this angle out. It's something like 37 degrees off the top of my head, but let's just work it out. That's 36.9 degrees. 36.9 degrees. And we've got, because it's must come in between, it's a right angle, that the angle here has got to act in between the two. There's 90 degrees here, it has to act in the middle. That's 45 degrees and 45 degrees. This angle here is 36.9 degrees. So we can say that, let's mark in a different colour, this angle here is at 45 take away 36.9 degrees, which is 8.1 degrees. So our final answer is 8.1 degrees to downwards vertical. That did get the marks, but it was actually sufficient to say it, but it was the bisector of it. It's a bit strange anyway. To downwards vertical. Certainly if I was doing this exam, even though there was one mark on it, if I had the time I would certainly work it out, but it was okay to say it was the bisector of the angle in between. Okay, that is that in 1 June 2016. I hope you found these videos useful. I don't think you're going to find another M1 video coming from me soon, I'm afraid. So, thank you and goodbye.